Hello everyone, so welcome to the lecture of this digital communication. So here we are just starting this digital communication of electronics and communication branch. Basically it is actually a unit 2. So first of all we will discuss the introduction to digital communication. As you all know, we have previously discussed the analog communication. Now, it is the time to discuss the digital communication because why we using this digital communication over the analog communication, we will discuss it in the next lectures. So let's start. First of all, in this lecture, we will just introduce to the digital communication. The digital transmission or digital communication is the physical transfer of data over a point to point or point to multi-point communication channel. Basically, as the digital is written over here, digital means that the data is transmitted in the form of 0 and 1 or in the binary format. Binary format means in the 0 and 1. So let me give you an example: optical fibers, wireless channels and computer buses. Optical fibers, and these all are kind of examples, uses the digital communication because in this type of channels we are using the binary bit data. Now we are just coming to the elements of digital communication. What are the elements we are using? First of all, we have the source of information, like whatever the signal we are transmitting from the source side. It first of all it is in the form of physical signal, or we can say it as the source of information. Then it is source encoder. Source encoder means the data which is coming, we are just encoding it or we are just converting it in the electrical form. Then channel encoder, then modulator and then channel. Modulator is modulating the signal for the longer transmissions. What do you mean by modulation? When we superimpose the high frequency carrier signal with a message signal and just we changes the property of like phase, amplitude and frequency of the message signal. Then we have the channel. The channel can be wireless or it can be wired. We can use here the optical fibers or simply the wireless channels. It is our transmitter side. Okay, this all our transmitter side. Now we are coming to this received side or receiver side. Then reverse this all. We have used modulator. Now in this side we will use demodulator to demodulate, or just when we use modulation of the signal, we just have to decrease its frequency to the original one, so we use demodulator. Then demodulator, then channel decoder, then source decoder and user of information. These two will decode the information from the electrical to the original form, and then the user will get its data in the physical form, whatever it is required. Now here it is written whatever I have explained you here. The information sources, it generates messages to be transmitted. Examples are data from computer, text data or teletype data. Source encoder, it assigns code to the symbols generated from discrete information source. The code word have n number of bits, each distinct sample having distinct unique code. If code word length is 8 bit, we can have 256 distinct symbols, 2 to the power of n. Okay. Channel encoder, I have already told you. Then we know that channel is the major source of noise. Due to that, there are more chance of getting errors while propagating through channel. Yes, uh, when we just transmit any data, there can be a chances that our data can get errors. So we use channel encoding. So to avoid that channel encoding is required. What to avoid? To avoid the this kind of error, we just use the channel encoding. In that, extra bits are added. In the transmitting side, we just add the extra bits and then just check it at the receiver side uh, if it is like whatever we just we just wanting. So if it is that, or if it is in the actual form, then we will get the correct data. Otherwise, we are getting the defaulted data. So these extra bits are called as redundant bits. Whatever the bits we are added, we are adding, like I am having a signal 101. Okay, it is actually a 3-bit data, and I am just adding one in the end of it, and I am transmitting this data. Okay, this is my redundant bit. Whatever I am adding at the end, or whatever the extra bit I am adding, it is our redundant bit. And at the receiver side, if I am getting this data, then it is correct, otherwise it is faulty. These bits are defined with proper logic. The redundant will be helpful to detect the errors at the receiver bit sequence. For that, we will be using different techniques. Digital modulator we are covering now. In digital modulator, the message signal is digital data and carrier is analog one. In most cases, we use sinusoidal waves. Some examples are ASK, FSK, PSK, MRI techniques. Okay, the channels are, it provides the link between transmitter and receiver. Channel may be wired or wireless channel. As I have earlier told you that it can be wired or wireless. So this is our channel. Now these all kind of problems we face generally, like additive noise. The noise is occurred due to internal solid state devices or register used in the channel. This is the internal noise or internal loss, we can say. Amplitude and phase distortion. This noise is occurred due to non-linear characteristics of the channel. Attenuation. This is due to internal resistance of the channel. Okay. This demodulator, channel decoder, source encoder, and destination is the reverse methodology of the transmitting side. Okay, now coming to the main topic of this unit, this is advantages of digital communication system. Why we prefer the digital communication, or why we use the digital communication over the analog communication. First of all, it is easy way of transmission of signal because we just have only 0 and 1 bit, or you can say the binary bit of data, and it is easy way of transmission for the signals. The connection of more calls through one channel, actually we can have the one two or more calls at the same time in the single channel. Multiplexing is possible using digital communication. The source encoding and channel encoding can be used to detect error at the received signal. Yeah, we can just use encoding and channel decoding. Okay, that we have earlier discussed here, that we just uh, use a channel encoder to add the redundant bit, and if we are getting the same data at the receiver side, then our data is good or right, otherwise it is faulty. So we can use this using repeater between source and destination. We can reproduce the original signal with less distortions. Yes, we can use the repeaters. In the previous semester we have earlier studied about the optical communication, in which we just use the regenerative repeaters. It is among that, it is also a kind of repeater which we use in this, that regenerates or initialize the data from its initial or original form. Okay, security is the major advantage of digital communication compared to analog communication. Yeah, as your data is in the form of 0 and 1 or in binary form, then it is difficult to decode it, or it is a very kind of secure data transmission. Transmitting analog signal digitally allows for greater signal processing capability. Okay, digital communication can be done over large distances through internet and other things. We can do this kind of communication over a large distance of area. Okay, it can cover the large distances. The messages can be stored in devices for longer times without being damaged, and the advancement in communication is achieved through digital communication. Okay, now coming to the disadvantages. First of all, the sampling error. We can, if we are having the data in the digital form, there can we face the sampling error. What is sampling actually? When we just convert the analog to digital, when we convert the data from analog to digital, we just have to sample, we have to use the sample and hold technique. There in the sampling we can have the sampling error. Digital communication require greater bandwidth than analog to transmit the same information. Yeah, it actually requires a greater bandwidth. The detection of digital signal requires the communication system to be synchronized, whereas digital, generally speaking, this is not the case with analog system. Basically, when we use the 1-0 format of data, we just have the system to be synchronized, because in some of the cases when we transmit the data 0 1 we just get unsynchronized data, or there can be a kind of delay in the digital signal. Okay, so it is another disadvantage of the digital communication. Digital signals are often the approximation of voice signals. We don't get the exact analog signal. Okay, there can be sometime a kind of error. Okay, now coming to the line coding, it is one of the most important part of this unit two. Line coding. Why we use a line coding? We will discuss here. A line code is a code used for data transmission of digital signal over a transmission line. Actually, we use the line coding, as the name itself is defining that coding of the signal over a line is known as line coding. Okay, this process of coding is chosen so as to avoid overlap and distortion of signals such as intersymbol interference. What is intersymbol interference? We will discuss it in the eye diagram. It is actually a kind of noise we can just uh, assume here. Properties of line coding. First of all, as the coding is done to make more bits transmit on the single signal, the bandwidth uses much reduced. When we use the line coding, the bandwidth reduced, and for a given bandwidth, the power is efficiently used. As we are just decreasing the bandwidth, our power will also get efficiently used. Okay, the probability of error is much reduced if we are just decreasing the bandwidth. Probability of error will also get affected. Error detection is done. We can easily detect the errors. If there is probability of error is less, then we can easily detect the error, and power density is much favorable. The time content is adequate, and long strings of ones and zeros is avoided to maintain transparency. Okay, now we can have the three types of basically line coding. Not this one. This is not a type of line coding. This is included in the bipolar only, because let's see in the next. First of all, unipolar. What do you mean by if anyone asks you what do you mean by unipolar, it is a kind of on off keying. Here we have the same kind of signal what we are transmitting. You will see here it is also of two types, non-return to zero and return to zero, NRZ and RZ. Unipolar NRZ means in this type of unipolar signaling, a high in data is represented by a positive pulse called as mark, which has a T duration equal to symbol bit duration. A low input data has no pulse. Okay, let me give you an example with the diagram. Here is the example with the diagram. Okay, first of all, we are having the clock up and down, up down, up down, 0 1 0 1. The clock is shown here. The data is like this: 1 0 1 0 0 1 1 1 0. Okay, now in the unipolar NRZ, your 0 will remain 0. Okay, and 1 will be 1. So it is your unipolar NRZ. Now coming to the advantages of it, it is simple, and the bandwidth is required is very less. The disadvantages are no error correction done, and the clock is not present here. This means, this doesn't mean that we are using here clock. This clock means that the clock do not affect any kind of this signal, because here we can see the unipolar and other signal is directly dependent of the data, not on the clock. So we are just neglecting the clock here. So we are using the this kind of statement that no clock is present. Okay, loss of synchronization is likely to occur. Okay, synchronization loss may be occur in this. So now coming to the next, unipolar RZ. In this type of unipolar signaling, a high in data to represented by a mark pulse. Its duration is T naught is less than the symbol bit duration. Okay, half of the bit duration remains high. As the name itself says, unipolar RZ. RZ means return to zero. That means the signal will definitely return to zero. If it is high, it will reach to high, then it will definitely return to zero at a time, at a half time, you can say. Okay, after reaching to the height of 5 volt or the positive one, it will definitely return to the 0 point for the half one. Okay, let me give you an example here. This one is a clock. It is 101010, and then here's the data 1010011110. Okay, now unipolar RZ signal will be, just look at here. This is our one. Okay, and we are discussing about the unipolar RZ. That means return to zero. It will return to zero at the half cycle. So when we are going to one, after the half cycle, it will just come to the zero. Okay, so here you can see it is coming to zero. Okay, and zero will remain the zero, then again one, then it would be one for the half cycle, and then again come to the zero, then zero will remain zero, then one, then fear, then it would be one for the half cycle and zero for the half cycle. This is the unipolar RZ. Okay, if I talk about the advantages of it, it is simple. The spectral line present at a simple rate can be used as a clock. So we are just using the clock here somehow. Okay. Now the disadvantages are that no error correction, occupies twice the bandwidth as unipolar and RZ. The bandwidth is much more in this. The signal drop is caused at the places where signal is non-zero at 0 hertz. Okay, this is our unipolar RZ. So in this lecture, we have discussed the introduction to the digital communication. Then we have discussed the line coding, in which we have already discussed the unipolar RZ and unipolar NRZ. Thank you so much for this attending this lecture. So if you are having any kind of query, you can ask in the comment box, and I will definitely going to reply you all. Thank you so much.